Okay, the next thing I want to talk about, just do a tiny bit on the actual web browser itself. This is kind of foundational as well, and you can see the next card in the list is where we get stuck into React. So there's just a little bit about a browser that it may be refreshing your knowledge rather than telling you anything new, but there are one or two little terms that you need to be aware of when we talk about browsers. The browser I'm saying there is an event-driven programming environment. You know, when you interact with a browser, and that by interaction, I mean you move the mouse, you click on something, you type something into a text box, you select a drop-down menu, all of those interactions are picked up by the browser, and it creates an event or triggers an event internally. And you can actually have JavaScript code associated with the web page that's currently being displayed. And you can have functions within that JavaScript linked with those events. So the idea is the user would interact with the page, the browser fires the event corresponding to that interaction. You have told the browser, run this function when a particular event occurs, and the function can do anything it wants to. Okay. And so all of the JavaScript that you write behind a web page tends to be concerned with reacting to events that are happening in the browser as a result of the user interacting with the UI. An event as well would be when if the web page sends a request down to a web API, when the web API response comes back, that actually triggers an event within the browser as well, and you can have a piece of JavaScript code linked to that. And we kind of saw that when we were using the fetch then kind of programming there the last day. It wasn't obvious that there was events going on there, but that's actually what was going on behind the scenes. Now, this is just a page I actually got from a presentation made by a guy called Douglas Crockford. I mentioned his name before. He's one of these kind of gurus in this world, so I just wanted to acknowledge. That's where I got the page. So what is being described here is the basics of how a browser actually works. So when you type an address into the URL address into the browser, or if you click on a hyperlink, which causes the URL to change, the browser goes into fetch mode. And by fetch mode, it sends the request out to the HTTP request out to the actual server. And eventually the server responds back with HTML and perhaps some additional assets as well, particularly maybe CSS, maybe some JavaScript. The browser then takes that HTML and it parses it. So it analyzes it and it constructs a JavaScript object representation of the HTML. And the JavaScript object representation is called the DOM, or Document Object Model. And it is essentially a hierarchical network of JavaScript objects, or a nested tree of JavaScript objects. We've got kind of a sense of that from last week, this idea of nesting of objects inside objects. So the DOM is critically important here now. The DOM is a nested tree of JavaScript objects, and it is a representation of the HTML. Having done that, the browser then goes into what's called its flow phase, and in the flow phase, it takes the DOM and builds another representation, which we don't really care about, called the display tree. And when the display tree is constructed, the browser goes into its paint mode, where it actually paints pixel by pixel what's on the screen. So all of that happens as a result of the URL in the browser changing. Now, assuming the page doesn't change, then the browser goes into this cycle of phases. And so we can kind of start from here. So the user interacts with the page. That causes an event to be fired within the browser. You can have a piece of JavaScript linked to that event. The JavaScript can do anything. Typically, what it might do is actually make a change to the DOM data structure because it has access to the DOM data structure, and it's just the data structure of JavaScript objects. So we would know how to potentially make changes. Now, whenever the DOM is changed, the browser will actually recognize that. You don't have to tell it, I've changed the DOM. It actually monitors the DOM. And if the DOM has changed by whatever means, and for now we're saying perhaps the JavaScript has changed it, immediately the browser goes back into its flow phase, which we saw from the previous screen, which means it reanalyzes the DOM, constructs a new display tree, and paints that updated display tree. And it can remain in this cycle as long as the user doesn't cause the URL in the browser to change. If it does, then we're back to the previous screen. So this idea of event, typically as a result of the user interacting with the page, the event triggers a piece of JavaScript which you have written. This JavaScript changes the DOM, which causes the browser to reanalyze the DOM. And as a result, because the DOM has changed, then what should be displayed on the screen needs to change. And it does that by painting the updated display tree. So that's how kind of browsers work at a very basic level. That's always been the case, and that is still the case. So hence, the browser is very much kind of event-driven in this sense and in the sense of the previous screen as well, a previous slide. So on the right, I have a very simple little HTML. The title there is document tree structure. That was the old name for it, but we now call it the document object model. Same thing though. And on the left, I am showing you the DOM representation of the HTML on the right. So the object, JavaScript object at the very top of DOM is called the document object, and it has one child called the HTML object. And then from there on down, really, the children depends on what is your actual HTML page structure. I said that the browser constructs the DOM, and what it does, in addition to constructing the hierarchy of nodes, they're called, actually, we refer to each of these things as nodes, okay? As well as constructing the hierarchy of nodes, it also builds in links between them to facilitate your JavaScript actually navigating the structure. So that's what I'm showing here. So for each node, it includes in that node a pointer to its first child and its last child. It also builds in references between nodes that are siblings, and it builds in pointers from child to parent. That's probably a bit too much, really. It kind of overdoes it. The really critical ones are those ones. And really, once you've got those references between nodes, what it means is that you can programmatically navigate the DOM, because you never know what the structure of the DOM is in a way. You need to kind of discover it programmatically. But these pointers essentially allow you to do that, and they're built into the DOM for you by the browser. Let's take a tiny illustration of that. Now, with this set of slides, which is over here, there is an archive. It's quite small, really. So if you just click on that, you'll download a zip and unzip it. And when you unzip it, what you will find is essentially this. So I'm going to pull that into VS Code. Okay, so we've just got some simple HTML pages. So if we look at this one, and if I start up my Go Live server, and it's showing me that, is that the page? Yeah, okay. So in terms of, I'm sure you're familiar with this now, but in terms of children and siblings, we would say that H1 and P are children of the body. We would say that H1 and P are siblings, and the div is a sibling as well. The div has two children. Okay, so that's what we mean by children and siblings. Now, if I open up the developer tools, really the console here allows you to write JavaScript statements. And what I can illustrate here is I can actually illustrate navigating the DOM structure that has been built by the browser for the current web page that's being displayed. Okay, and so rather than typing it out, because my typing isn't good, I've just saved some ones here. So if you take this one, document.body.firstElementChild. So document is the one at the very top. Body is obviously the body of the body node of my HTML page. And the first child would be the H1. Yeah. So if I just grab, and this is just JavaScript object navigation that's going on here. This is the dot notation that we've talked about. That's all that statement is doing. So if I just do that, if I hit return, and you can see it's kind of nice, like it's actually highlighting the part. Well, it did. Sorry, if I hit return, it comes back with that anyway, telling me right that expression corresponds to this particular part of the DOM. Now it's showing me the response in terms of HTML, but really that expression evaluates to an object. Can I prove that? What you're seeing now here are all of the properties of that object. So that's my way of proving to you that that expression is actually an object. And these are various properties. And these are the properties that the browser assigned to this particular object when it was building the DOM. Some of the properties actually could be functions. I didn't mention this when I was talking about objects there last week, but when I was talking about objects, I gave the impression that it's only primitive values or nested objects that can be the value in a property. But in fact, the value of a property could be a function. And you would invoke, that function can be invoked by referring to the property name within the object, if you like. So anyway, although the expression is an object, when I hit return up here, it showed me, mainly as a kind of a better user experience, it told me which particular part of the HTML it corresponds to. And there are other examples as well. So really all I'm showing by way of these examples is that we can programmatically navigate this DOM structure using JavaScript, in this case dot notation, but you could use the subscript notation as well. Just do one other. So that looks, it picks out the paragraph. Okay, so that's this idea of navigating the actual DOM, but navigation is okay. But what would be more interesting is if I change the DOM, what's going to happen? And the next slide is demonstrating that. So the code on the right here actually adds the click OK button or click button at the bottom. So if I just do that, it's going to be a bit slow now, but let's just take it step by step. So the first thing I'm doing is this. What this is going to do is it's going to create a button element, but it's not actually attaching it to the DOM. It's just creating it in memory within the browser. And it's an ordinary JavaScript statement, as you can see. So let's do that. So I've created a button. The next thing I do is I create a text element. The next thing I do is I attach the text element to the button. I wouldn't worry about the actual JavaScript methods here now, because we're not going to be doing this kind of stuff. We're going to be doing it at a higher level, if you like. But I'm attaching the text to the button. Now on the left, you'll see that I still can't see the button because I haven't actually attached it to the DOM at all. When I talk about the DOM, like the DOM has other parts to it. Clearly here, it looks like I'm interacting with the DOM, but I'm not attaching it. I'm not attaching the elements to the active. Sorry, I'm using the DOM API here, okay, but I'm not actually, I haven't yet attached anything to the actual DOM data structure. I kind of leave it at that really, but which is a bit vague admittedly now, but here's the critical line though. This is where, and I suppose the statement kind of highlights it here. It looks like I'm actually accessing the body of the document, whereas the earlier statements weren't going near it at all. I'm actually accessing the body and taking the first, well, really the third child, because the body has an array of children. And in my case, it has 3. I think it had the header, the paragraph, and the div. I'm accessing the div part, and I am appending the button that I've declared to the div. And so when this statement executes, I will see, well, sorry, when this statement executes, I've made a change to the DOM data structure, and the browser kicks in and it will do a reflow and a repaint of the DOM, and I'll see the button then appearing on the actual web page. As in, did I copy that? And there's my button. So that demonstrates this idea of when you change the DOM, the browser will reflect that change in the UI. And we've seen it by virtue of the very last line there. So the DOM can be navigated and the DOM can be amended. And we will be doing a lot of DOM manipulation and amending, not using this. What I've been using here, is what's called the DOM API, but it's a very, and that comes with every browser. Every browser has this API built into it for interacting with the DOM, but it's very low level and it's not very developer friendly. Single page app frameworks and indeed jQuery, which I mentioned back there earlier on, they're built on top of the DOM API that's part of the browser to make this kind of DOM manipulation coding more developer friendly, if you like. So it's all around this event-driven model. So the statement now saying here is that the browser has an event-driven, which I've talked about. It has a single-threaded programming environment, which arose the last thing. It just has one operating system thread. And it's also an asynchronous programming environment. What the asynchronicity kind of refers to there is there's no, you can't predict the order in which events occur because you can't predict the user interaction. And even if a number of events kind of happen in quick succession, the JavaScript code that runs in response to each of those events could happen in any order. You cannot predict the order in which they run. And there's also a kind of a delay between event occurrence and JavaScript execution. And that you need to be aware of that, I guess, when you are writing your JavaScript code to respond to an event. At the bottom of the slide, I'm just kind of outlining the different nature of the events, which I've already alluded to. Mouse moving, typing something into a text box. When a web page loads an image, that's represented as an event if you want some JavaScript code to respond to the loading of an image. Clicking on buttons, entering text box, etc., etc. This is kind of the full, well, nearly the full list of events that are available to you within a browser. They all begin with on something, and there's more of them. So it kind of handles all possible situations, really. So you can write JavaScript code to respond to anything. The JavaScript code that runs as a result of an event occurring is what's called an event handler or an event listener. How do we associate, and it's really just a JavaScript function, how do we associate an event listener with a particular event? And there are two programming styles, the imperative style and the declarative style. In the declarative style, you actually express it in the HTML. In the imperative style, you actually program it in JavaScript. This was in the very early days now of web app development, I suppose. We still do it imperatively and declaratively, but using higher level frameworks and APIs rather than the low level DOM API that I illustrated there a few moments ago. And I just got one or two quick illustrations of them. I don't want to spend too much time on them. So if you just look at that piece of code there, I've got a function, and it's so old now that I've actually used the var. The var keyword is essentially the equivalent of let in modern Java. So that tells you how old this piece of code is. Sorry, go back to that. Just to explain what's happening here. So I've got a function, and here's some HTML, and I've got a text box, and I am declaratively associating the function that I've declared above with the function that I've declared above. I'm declaring it with the change event for this particular HTML element. In other words, when the user types into the text box and hits return, when they hit return, that causes the browser to fire the onChange event for the text box. Events are associated with a particular part of the DOM. In this case, the DOM element, the DOM node corresponding to the input text box. When they hit return, then that causes my function to execute. And what I'm doing in the function is essentially I'm taking the text in the text box and I'm uppercasing it. Again, I wouldn't worry about the specifics of this code. We won't be writing code like this. We will be doing this kind of stuff, but not using this style of coding. So down here, I'm kind of illustrating what happens. You can, if you want to play with that, because it's part of the archive. Okay, not very exciting. And the code behind it is this file here. But again, you can glance at it, but I wouldn't spend too much time on it. So all we're illustrating is, so what we would say is, this is an event handler or an event listener, and specifically, it's an event listener for the text box for the on-change event associated with the text box. And I'm associating the event listener with the text box using the declarative using the declarative programming style. That's a bit of a mouthful. The other way you can associate an event handler or listener is using the imperative style, where you actually do it programmatically. That's what's going on here. And you just write a lot more, JavaScript to do it. And kind of what's going on here is you're associating a function with a particular DOM element. Again, you can glance at it, but I wouldn't spend too much time. And you can play with it. You have the source code in the archive that we downloaded there. So the DOM API is what we've been using in this lecture, in that previous slide and the one before it. And when I was playing with the DOM from the developer tools console, I was using the DOM API, but it's a very low level API, not very developer friendly. And it's also kind of browser specific. And so for all of those disadvantages, that's why the jQuery library came about. I should have checked who developed jQuery, but whoever developed this, whether it was an in-house project or some sort of open source, the jQuery API sits on top of the DOM API. And it just makes all of the stuff that I have been doing earlier on just a lot easier, as in you write less code. It's also browser agnostic. It will run the same way on every browser. So it actually kind of detects what kind of browser am I in and determines how it should interact with the DOM API of that particular browser. So it does that internally so that you as a developer, you don't have to worry about it. The disadvantage still though, when you were using jQuery, and jQuery is still very popular, but there was no best practice in terms of how you should structure your code. So you still tended to finish up with quite spaghetti code that was poorly maintainable, really. And so what happened next then was we had the single page app frameworks, which also sit on top of the DOM API and sometimes use jQuery internally as well. And that's where we will come in. And specifically, we're going to look at the React single page app framework. Right, that's that. I suppose, even though I have a few minutes, but I suppose there isn't much point. The next thing we will do is to actually start looking at React. So 2 lectures next week. Now there's no labs associated with this tab. There are 2 labs associated with this one, but I suppose realistically you won't be able to get into these until I have done. I will need 2 lectures really to cover this set of notes. So fortunately, some of next week's labs are going to be kind of redundant. You could have a crack at them if you want to see whether you could get anywhere. You could actually probably make more progress with this one rather than this one. Maybe that's a suggestion, just see how you get on with it. Okay, I think I'm going to stop there unless anybody has any questions. just maybe before I, seeing as I do have a minute or two, at yesterday's lab, some people had an issue with this. This little icon here, what it does is it shows you how much work you have been doing on this module. It kind of records how much time you've been spending on the labs. So here am I, and here's how much time I spent on them. And I will be honest and say I will use this data when I'm assessing people, but some people weren't getting any display when they clicked on that icon. And what I'm asking people is, if you click on this icon and you just get a blank page, could you open up the developer tools? So by that I mean, now I do get something, but open up the developer tools and you will get an error. It looks like I'm getting an error as well, but what I'm asking you to do is take a screenshot of the error and just send it to me via Teams, really, MS Teams. And I will show that to the person that actually, it's one of my colleagues that actually has developed this whole tool, really called the tutors tool, because he's interested in debugging why it doesn't work for some people and does for others. I know there are one or two of you now that I was talking to yesterday that had that issue. So you definitely know what I'm talking about, and you can send me on. I guess all I need is one or two examples just to see if Eamon, my colleague, can actually debug what's going wrong there.